So thank you so much, first of all, for having me. I truly and thoroughly enjoyed doing these sessions. I mean, I think this is my second time presenting at Teams Nation. Love the fact that it's all community driven, and I get to talk to you guys about things that are near and dear to my heart, like including what I'm going to talk about today is essentially about our mobile apps. And the reason I decided to talk about our mobile apps is because in all of the MVP summits that I have done, in all of the airlift sessions I have done, mobile is like, yeah, it's also there, right? We basically show the diagrams like a couple of times, but we've never gone into the depth of what mobile is about. And the reason I felt like doing it is for two reasons. So one is that our mobile apps are actually pretty well loved. I mean, we have star ratings about 4.7, 4.8 on the stores. The NPS is incredibly high. There are certain people who basically tell us that iPad is essentially one of the best experience of Teams that they have ever used. And it's a small team within Microsoft Teams team, like that reports into me, which kind of makes this happen on a regular basis. So what I'm so what I'm basically thinking is that, okay, how do I essentially, bring this to more light? And the the other reason why I kind of wanted to talk about this is because we actually have a huge amount of users that use it, like it's in hundreds of millions, and that's the other reason why this story needs to come out. So what I'm going to do today is essentially just talk a little bit about the product journey, and then swing it into like our architectural journey. How do we think, how do we build this thing, and how do we ship it, and I'll just open it up for questions towards the end. So let's dive right in. So our product journey is pretty interesting. So when we started out with mobile in 2017, 2018, CYS for calendar year, the mobile apps were largely companions. Like the idea was that, okay, you can also have a Teams experience through this, but it wasn't like, okay, this is going to be your primary experience. When I joined the team in 2017, these apps were just coming to life. And there were a lot of glitches in the sense that, okay, if I were to go on an airplane and try to use GoGo and try to send a message, it would just not go. If I was essentially in an elevator and I was trying to send a message, it would just get stuck in sending and the checks would not come. And but the idea was that these were companion experiences. You were essentially using them infrequently, and not something that was completely primary for us. It was essentially in 2019 when I basically got to this point where the mobile apps became fully functional in the sense that you could actually have a whiteboard inside them. You could essentially do widgets and even things like adaptive cards, and you could do things like quiet hours. And if you were to send a message, you could actually send a voice message. I made it sure that this thing would actually work when you are in an airplane and you are on the free GoGo network. I still remember that there was and the way that I did it is I would basically send the same image on Teams, the same image on Skype, the same image on WhatsApp, and I would record those sessions and say that, okay, WhatsApp, the image basically just goes right away. On Skype, it flutters. On Teams, it just doesn't happen. So we ended up creating like a virtual airplane kind of a network within the 12th floor of Lincoln Square, where we are all seated. We created like an equivalent of an edge network within the building and encourage all of the engineers to use it on a daily basis and then just grind it out to the point that we could get to this thing that the message would always send or the call will always connect. Today you can actually connect a call using Teams on an airplane. I do not recommend doing it, but it's possible. So 2019 is when we essentially became fully functional. 2021 is when we said, okay, we're going to push it to the next level, which is how can we even add more functionality, but get to the point where it is not just the core mobile team building functionality, but anybody within the company and outside the company can contribute to this experience. So the example is Cortana team pretty much just owned the entire Cortana experience within the app. My own calendaring team owns the entire calendaring experience, but it's not part of the core mobile team. The search team within Microsoft provides the search experience. And now, if you fast forward, we have all of the Viva stuff essentially coming in. We have essentially a lot of walkie-talkie is something that we just recently shipped that is not done by my team directly. but it's essentially done by our frontline team. So the idea was to convert the application in a short duration of time from something that was a companion experience to something that's a full-blown experience to something that now enables 1P, 2P, and 3Ps to essentially add to the app and keep on making it super rich. And the team is like super proud that we have been able to do it in a manner that we have SDKs for a lot of these things that I'm going to talk about when we basically get to the architecture section. But the app actually feels like super rich and super useful, and not just a companion experience. You can sort of rely on it on a regular basis to get stuff done. Now, why this is actually important is because of this, right? So I'm going to show you a timeline of what we had to achieve versus what some of our competition had done. So if you look at WhatsApp, quickly going to go through this. It's about an 8-year window by the time all of these things basically light up. Now, WhatsApp is essentially also growing significantly during this time period. Now, when we think about Teams, this is what happens. Like, by 2018 half, like in a year and a half, we had to condense everything that was happening within WhatsApp and essentially put it inside Teams. So the reason I'm super proud of this journey is because this specific team worked super hard, ground through a lot of technical challenges to get to the point that, for example, State Bank of India, which is one of our customers and is essentially using now Teams for compliance reasons in India, even in the remotest small town, Teams would work on the on like not like where it says LTE, but the bandwidth is actually fairly limited. So our timeline got super condensed, and that's just one view of why this was essentially a pretty hard technical challenge for us. So how did we do this? Similar story. So first of all, rock the basics. Like if you cannot send a message, it's not worth it. If you are not doing it in a manner that you can play to the growth of the users that they were coming in, like when the pandemic hit, a lot of schools deployed iPads and Android devices, and we had to immediately support it. At the same time, we had requests from Amazon to go in and light up mobile on Kindle Fire devices. We had requests from Meta to go in and light up Teams on a Portal device, which we all support at this point. Then we had our own phone systems, which are also powered by the same application as well. They're all running on Android. And the challenge was that how do you essentially go through so many different device types? How do you basically go through all of a sudden a huge increase in demand, and at the same time keep on adding features while rocking the basics, and essentially ensure that you are putting your architecture forward for the next 5 years. So because again, if you are in that condensed timeline that I just showed, we took a lot of shortcuts to build these apps, like no doubt about it. I mean, there is a spaghetti code in there quite a bit. And then the last one was that we had we had requests from our partners, including certain airlines, which were like, okay, before the pandemic, like how can we run the entire digital operations of a specific flight on Teams, and how can we put our line of business applications in there, and making sure that we had a pretty robust platform both on React Native on the website to enable those scenarios was super important for us. So that's essentially the journey. Now, what do we do with respect to fundamentals? So these are the kind of things that we essentially track, and they determine whether somebody's going to like the experience or not. And we have seen our star rating change and our NPS change based on what happens over here. One of the ones that I want to touch upon is battery consumption. Like the single most important thing when you are using a mobile devices is that it should be able to sip battery essentially as things are happening. It should be able to sip bandwidth. So we had to go in and work and optimize our media stack for iOS and for Android, one on OpenGL side, the other one using Metal, to essentially ensure that doesn't matter how many videos we were showing, we were optimizing it for battery consumption and bandwidth utilization. Message load performance is super key. If you get a notification, you tap on something and it takes a while for that message to load, you'll basically have lost the user. It's not perfect when we have to still tenant switch, right? I mean, it takes a while for the tenant switching experience to happen, but that's because we have to tear down the entire app and put it back up again. And what the team had to do over here is that our services were designed for long polling. We had to move it to a push mechanism. We had to create a new service that would essentially collate all of the different kind of messages and call notifications that were essentially coming in into the device, filter it on the server so that the client could essentially not have to do work of hiding notifications, what it was doing before, and only send the ones that were relevant to the client. So again, saves battery because the client is not waking up on irrelevant notifications, for example. Offline state handling, super important. That go experience that I talked about, like, the client has to continue to work when the network isn't available. Like, it should basically start caching the message and it should automatically retry to send them. Like, and then, ANR and crashes were super important for us because, we said that, okay, if the client is constantly crashing, then again, like, you're going to have a pretty bad experience. And then similarly, like I talked about device matrix and COGS, and then the other interesting thing was that we have a single client that works across work and life. In work, we support large scale enterprises, we support small businesses. In life, we basically support end users. And getting a single client to basically work through all of these different scenarios is a pretty challenging problem. And we had to go in and work with our identity team, for example, to make sure that we were using the right libraries for authentication that could, on one hand, do CAE and POP, which is like the holy grail uh, of ensuring that you have high quality security on your authentication mechanisms, to supporting like a Microsoft account, which anybody could essentially use, to for their let's say homeowners association or for calling their friends or family. So a single app working across all of these kind of scenarios is pretty challenging. Edu was another interesting one where we had like schools and students all using tablets to do their homework. And how do you then integrate like whiteboard? How do you essentially integrate PowerPoint Live? How do you integrate assignments? How do you integrate the ability to see teams and channels as in a very different view compared to what you see in an enterprise ecosystem? And then supporting things like CarPlay and Android Auto, which all of a sudden, like we had to shut down at the start of the pandemic, but they became sort of pretty important as the pandemic sort of started to wind down. So that were the other challenges, and very quickly, like the extensibility story has been super important for us, and that's the only reason why we have been able to do things like Viva, things like org chart. So now what I'm going to do is talk about more of the architectural journey and switch over from the what to the how, and why this was super important. So again, like this is sort of what it looks like. Won't basically go into the specific details of the timeline. So the core principles that we started out with, they were super important. So one of the things that we said, and this basically came back from some previous mobile experience, where it became pretty evident to us that if we wanted to have a great experience, we had to keep the core things as essentially native. And what that basically meant is that in certain scenarios, we would be coding specifically towards Android and specifically towards iOS. But conforming to platform specific patterns and device capabilities has enabled us to ensure that we have a high quality experience on both ecosystems. Then the second one is separation of presentation layer to allow multiple form factors. If you basically start thinking about an Android app, it has to support a phone system, it has to support a tablet, it has to support a meeting room system, it has to support an Android phone, it has to support a Facebook portal, it has to support a Kindle Fire, it has to support a Surface Duo, which is essentially dual screen device. And if we did not separate our presentation layer from the business logic layer effectively, then we would not have been able to take the same code and then allow it to scale to all of these different form factors. And because we made that investment, that helped us significantly in getting to the point that it's the same app that runs on all of these things that I just described. And it runs flawlessly in the sense that despite all of these different device types, we are able to ship these apps once every 2 weeks to to the plethora of the ecosystem, including multiple app stores in China, and it sort of works like clockwork. So investment in architecture and abiding by this core principle was super important for us. And then last one is essentially very similar in that sense, like high degree of runtime configurability, like being able to say, what am I running on? Why am I running on this? And how do I essentially change myself to have the optimal experience of what configuration I'm running on? And our desktop apps do that to a certain extent too, in the sense that the same desktop app also runs on the MTR. But on mobile, the configuration and the device footprint is much more enlarged compared to what we basically do with a desktop app, because it only has to deal with Windows, Mac, Linux desktops, and a meeting room system, which is essentially a specific pattern that we certify. So that's the core principle that the team used. Now, I basically was talking about building as native apps. Like there are significant advantages for us. Like we could have basically gone in and said, oh, we'll build the whole app in React Native, or we are basically going to go and do code sharing with our desktop apps by doing essentially like leveraging the same web tech that we already have. What we realized is that the mobile devices are not as powerful, and the second thing is that both Android and iOS have like really vibrant ecosystems when you are building native applications. So the model that we use is that certain functionality, we basically build it in C++, and then we can compile it to the two separate platforms. Our media stack is a classic example of it. We don't have to build it twice. But when we are talking about laying out the data, and we are basically talking about presentation layers, those essentially are built for the platform. And that is why you basically get the smooth scrolling on iOS and smooth scrolling on Android. And the other reason why we kind of did it is because we want the users who are used to specific patterns on those operating systems to be able to follow that. Like, so if you know how the back button behaves on Android, we kind of want the app to feel as if it is essentially built for Android and, follows the same back button behavior and semantics versus taking like, our own interpretation of a UI and then teaching you how to do things. Then the single most important thing was essentially extensibility. So for extensibility, what I basically came up with is this, right, which is there are certain experiences that are secondary experiences. React Native is great for them. And so the example would be the org chart module. People do not open it as often. Another example is the stuff that we have just basically done for Viva, where that entire Viva feed is essentially built in React Native. It's a separate application altogether. And then there was this whole idea that, okay, we also need to go in and enable like extensibility, like, on the messaging canvas on, or essentially like, the apps that our users are used to. So for example, if you can see a Jira board inside the desktop app, you should be able to see the Jira board inside the web app too. But it comes with the same set of problems as a desktop app, which is how do you sandbox, how do you provide security? So the mechanisms over there are very similar in the sense that we use WebView and web extensibility to to provide a high quality experience for our third party applications over there. This is sort of a simplified component diagram that I was basically just talking about. So we do have a separated data layer, we have a separate network manager, and these are very, very important for us in terms of being able to go in and get to the point that if you do not have a network manager, for example, on the mobile app, where you have to sip bandwidth and you have to sort of ensure that you're keeping connections open when you need to, you are shutting things down when the device is running low on battery, or you are essentially like keeping connection alive when latency is high or jitter increases, and let's say each part of the application has to manage on its own, it will not work. Like we realized that early on that we have to have like single point of contention on some of these things to optimize. Then the data layer is super important because we kind of want to provide an offline experience, and we took a big bet on SQLite over there and optimizing the entire SQLite layer. And the other thing that it also does for us is that it separates the concerns from the UI layer in terms of doing compute. And what that means is we can actually have multiple threads, one to access disk storage, one to access network, another thread to essentially take this data and stitch it together, so that by the time it goes up to the presentation layer, it's already in the form that is essentially optimized for display. So so this is essentially like a high level component diagram of what this app looks. Now the beauty is, and this is why I kind of wanted to talk about mobile in the first place, our desktop apps over the last 2.5 years have converged to this exact same architecture, right? I mean, we now have a client data layer which did not exist in our data app. In fact, we're going to tinker and tweak with taking the entire client data layer native so that we can have even much faster chat load times on the desktop app versus essentially keeping it in the web layers that it is today, even though it is separated out through web workers. We basically have just moved to a singleton network manager kind of a configuration in the desktop app, where instead of having like a separate long pole for the messaging side and a separate long pole for the calling side, it is all essentially coming through the single pipe now. The desktop app is also very similarly moving onto a separate view model and presentation layer. So what's interesting is that across all of our endpoints, the architectures are sort of converging, and these two disparate systems and teams basically feed off of each other. But what we are seeing is that the desktop app is adopting more and more of the mobile patterns to provide the 99.99% reliability that I kind of want from the client. And because we had essentially done this on mobile first, because of the flaky networks that the mobile apps run into, that entire experience is super useful in making our desktop apps even better. Uh, then how do we do this, right? So we basically have a few sort of core components that we leverage. So Teams UI, it's essentially what we call a homegrown UI library that sits on top of the controls that basically come from iOS and Android, but it provides a level of abstraction so that a button is a button is a button. We basically had the scenario where you know each team, like when they are basically building a specific experience, would directly use the native UI libraries for iOS and Android. And then we got to the situation that button styles would be different, or we got to the situation where the color of the button would be different. We said no, we're just going to go in and build our own abstraction so that and a developer who is essentially building an experience for mobile doesn't really have to think about what should be the size of a button, how should it flow, what should be its pixel density. And similarly, I already talked about the data layer, the networking layer, and the sync framework. But these separations have essentially allowed us to get to the point where the application can still feel performant, can still feel responsive, as it is trying to, do a meeting, but then at the same time, essentially load a message because the notification came in while the user is on a meeting, while sipping battery end to end. Now, I just talk about Teams UI, a couple of things like it is essentially part of our scaling as effort to achieve consistency, like I said, but it's also becomes a common design language for the design team to head out to the dev team. They don't have to go in and specify the details of every single button. They can basically just say, okay, this essentially is a standard button, and everybody knows and understand what it means, how it flows, and it improves our development times because most of the engineers do not have to go to the nitty gritty of applying specific styles to it. Very quickly talking about the sync framework. The sync framework is actually pretty interesting because it acts as essentially as an aggregation layer essentially on the client. Now the idea is that over a period of time, some of this we are even going to move further to the server so that the mobile app is doing even less. But what it does is that, okay, let's say the client has to talk to 5 different services in parallel to get a specific data set. Okay, it has to call to the roster service to get the roster. It has to call to the messaging server to pull in the message, or it has to essentially call into the call monitor service to log some data. The idea is that this one place essentially acts as a single orchestrator, so it can optimize of what needs to happen at what point in time. And essentially, let's say you're trying to log some telemetry information, but you are essentially running on a pretty constrained network. Then the sync framework can go out and say, okay, this is not a high priority task right now. It can essentially go on to the back burner, and I need to go and optimize more for the call at this point in time. And this has, again, something that has been super important for us in delivering a high reliability, high quality experience. And then we can basically do batched writes in the background, and it fine tunes performance quite a bit. Data layer, we use SQLite, and we're pretty happy with it. Much more happier than IndexedDB on desktop. And in fact, one of the things that I might be doing in the next 18 months is to move the desktop app, both Teams 1.0 and 2.0, to start using SQLite, because because of the performance differences that we see, and they are catastrophically different in the sense that if it takes the app about 100 milliseconds to fetch a specific piece of data at the 95th percentile on IndexedDB, what we see is that on SQLite, that number is like 10 milliseconds, 5 milliseconds. It's some order of magnitude difference in terms of performance. We have tried, to get the Chromium performance of IndexedDB much better compared to what it is today. But again, what we are seeing with SQLite is significantly better. So one of the things that I'm having the team investigate now is that can we standardize on SQLite across the board, and that improves the data fetch for us quite a bit. And we can build it in a manner that we can have a single client data layer that can run both on iOS and Android and our desktop apps, because we'll basically just build it in C++ and leverage it across the board, just like we do it for our media stack. And we hope that it's going to, bring consistency across the board, but then also, improve the performance of the desktop app quite a bit when we basically see the lag in responsiveness and all those kind of things. We basically do disk first. That's the other more important thing, because again, if we have a message on the disk, we want to render it from the disk. We want to render it super fast and avoid as many round trips to the network as possible. And again, having a robust data layer has been super important for us in that sense. Network layer, I basically just talk about it, again, by having a single choke point and orchestration, it allows us to ensure that we are not keeping too many connections alive. We're not taking over too much bandwidth. And it really keeps the call record simple as well, because the people who are trying to do anything with the network, about the layers above, they do not have to worry about any of these things like token management or service endpoint management or keep alive connections or any of those kind of things, or retries. The single layer basically handles it end to end for anybody who's sitting on top. So then some of these challenges I talked about, but I basically will talk about again in terms of what this team basically goes through and why this basically becomes so much more unique. And again, I talked about low-end devices and the plethora of devices that this runs on. Message format and HTML parsing, because we were built as a web app first, a lot of our data is essentially in HTML. People actually like to use HTML within their messages as well. So when you're doing copy paste from a website, for example. So we had to invent our own parser so that we could basically go and render those messages natively, for example. But then this one is the single most has been the single most interesting thing for us. Till 2019 or 2020, we had a pretty significant footprint of users, especially like frontline workers, who were running on an iPhone 6 or a Samsung Galaxy S3 or 4. In their day, these phones were actually pretty powerful. But as time has progressed and OS has become more bloated, the needs of the hours have increased in terms of the features and functionality. These basically become like low-end devices in some ways. And when I look at Android, we have to basically run on everything from a Xiaomi to a top-of-the-line Samsung. And when I say Xiaomi, I don't mean that Xiaomi doesn't make top-of-the-line phones. They do, but there are essentially phones that you can buy for $200, $150, specifically in developing market, where we do run into battery network constraints, and also in terms of CPU and GPU constraints. So we have a lab and we test the application on all of these constrained devices, and we have spent an innate amount of time optimizing. But what that has done for us is that it actually makes the high-end devices operate even better. And I'll give you one example. I am currently running on an iPhone XS Max as my daily driver. This is a 3.5-year phone at this point in time. And I have specifically not upgraded to an iPhone 13. And I similarly have a Galaxy as well. Because I just want to experience what it would be for somebody to be essentially running on a low power device. And that also gives me and my team a sense of what a significant population of our customer base basically goes through on a regular basis. My iPad is still an iPad 10 Pro, I think, or an iPad Pro, the earlier one that came out. Haven't upgraded that either in about 4.5 years, and I use Teams on it on a daily basis. And that those kind of things basically force us, for example, like I was saying, to push notification filtering, sending configuration changes gradually, or eliminating the number of round trips that we were essentially doing, or keeping services alive in the background. Very quickly, in the interest of time, since we only have like 10-15 minutes left and I want to open it up for questions, HTML parsing I basically explained, where this was essentially a grind for the team to constantly go through and get to the point that we could have the same high fidelity of rendering on mobile that we basically have on our desktop and web apps for any kind of message that essentially comes in, including like parsing the message, shrinking it to the right form factor, and being able to display it. Form factor challenge has always been the case for us. Like I was explaining, like runs on 1,000 different things, but you have to optimize the UX for each of those form factors, and making sure that the application is super modular is very important. So for example, if the app is running on a desk phone, it basically just has to boot directly into the calling experience, and it has to boot into that calling experience like super fast. So again, this is an example of how, by putting together a modular architecture and like putting together an extensible UI mechanism, the team has been able to take a single code base and run it on several different form factors with a high quality experience. Very quickly, I want to talk about extensibility in terms of what we do. So there are three ways in which our team and external teams can essentially build on top of our mobile applications. So first is native. It is essentially a deep integration. Search is a classic example of that. They essentially own both the iOS and the Android components. We help them integrate them in. React Native is another example where it's today it's only supported for teams within Microsoft, and like so if let's say some team inside Azure wants to go in and put something into our mobile app, and they can send down a React Native bundle. This bundle essentially lives on the server. We can dynamically pull it in at runtime and load it in the non-startup step. So the team has actually done a significant amount of optimization for app startup sequence, for example, so that even if we have to start React Native within the app startup sequence, we are essentially doing it in the post render step, so that the application is not bogged down, for example, in trying to load the entire React Native libraries and spin up the React Native VM. The web VM or through the web view is very similar. The advantage of the web view is that it allows our line of business application developers and third-party application developers to be able to go in and write like an application for mobile web and then just host it inside Teams without having to do a lot of tweaks onto their UI library themselves. We provide the SDK, for example, that would allow you to access location and camera, but because it's our SDK, we broker the permissions on the device. We are able to essentially ascertain that any application is not able to go rogue and pull in users' data. It's always running through the sandbox. So this is essentially a high-level diagram of what that means. Like specifically, when I talk about the web-based platform, as you can see, it goes through a Teams mobile core API layer, which then essentially ensures that we provide the right level of sandbox and security that is necessary to protect our users in every single scenario from third-party applications. And that's why third-party applications had to go through a certification process, and you have to tell what kind of permissions they're going to be asking for, and and uh, uh, and that essentially ensures the security of our users, and ensures that we are running with the right level of compliance, even when third-party applications are hosted essentially inside our mobile app. These are sort of the developer tools that we support. Like you can use Visual Studio Code to develop. You can build it on top of Azure to store your data. You can try things out with Chrome if you're doing a web-based application. We support like Android Studio and Xcode as well through our extensibility mechanisms. But overall, like what we have seen so far is that this is pretty good way for both internal Microsoft and external to Microsoft to extend our mobile app end to end. Another things that I kind of want to touch upon is like, how does this all work then? So we kind of have this contribution paradigm. And what I mean by that is actually pretty interesting. I'll go to the next slide to explain that a little bit. So if somebody wants to contribute an app, it basically goes into the app drawer. And this is essentially a contribution site. So you can essentially light up your app over here. This becomes a launch point. Similarly, so these are examples then of contributors. So these are the apps that are not built by us. Like, so the organization app is a complete React Native app. The saved app is a native app. The calendar app is a native app within the Teams ecosystem as well. This is yet another contribution site. So save, if you see over here, can essentially also go into the overflow menu. And we have a mechanism by which it can enlist itself over there and then just provide what happens when the user clicks it. And it's essentially through an SDK. So the person who is essentially building this this saved experience doesn't really have to go in and understand the nitty-gritty of the message overflow menu. They basically just say that I want to be here, and then we take care of the rest. So that's what this example explains. The other kind of things that I already talked about, like in terms of how we have essentially come up with a very specific UI language. So our designers can essentially now code the entire UI in Figma itself. And when they say it's a button, it's a button. We translate it automatically. The developer doesn't even have to do anything in order for this translation to happen. And then the last one that I basically talk about, just to recap the specific challenges, data persistence was a lot of issue for us. Message parsing was another issue. Separating write and read paths, and making sure that we have a very robust degradation of experience if we get to the point, for example, where the network is not available. So again, in a nutshell, the entire journey has been like one of the most fascinating experiences of my career. Again, squished timeline compared to what you saw, for example, to our to some of the applications that were already existing and our gold standard like WhatsApp. And at the same time, like growing demand, and at the same time building extensibility mechanisms so that we could essentially light up more richness into the application, while we were essentially trying to figure out how to make it like super robust and loved by our users. So that's pretty much all that I have. So I'm going to stop presenting, and I know we have some time, so I'm very happy to take questions.
So we've not seen any questions go into the chat. So if anybody has questions for Rish, then please drop them into the chat so that we can see them. Looks like you've answered everybody's questions, okay. Rish.
Well, then in that case, I want to be finishing early. Being going to be done in like 40 minutes. Well, I mean, I thoroughly enjoyed doing this, but if there are any other questions, I mean, I'm on Twitter. You can essentially always ask it, and I would be very, very happy to essentially answer them. Like Tom's question is, does the mobile team? Yes, every single Android client, everything is with the mobile team. It's the same code base, Tom. One thing to rule them all across MTR, phone system, Android tablet, Kindle Fire, Facebook Portal, and Surface Duo, and Android phones. Okay.
Well,
cool.
In that case, thank you very much. Very interesting to see how you've developed it, and great to see the mobile app. Use it all the time. So
awesome.
Yeah, excellent. So for everybody else, and Rish as well, you're welcome to join. We do have at the top of the hour the Teams Nation party, and Alt VR is kicking off. So please do try and drop in over there. But yeah, perfect. Thanks a lot, Rish, and thank you everybody for attending today.
Yeah, bye.